recording, you'll see a message on top of your browser right now, and it's going to get up to 95% really quickly. So it's not like we're going to have to hang around. It should work pretty quickly.
Do you want me to go over again what I described before?
Yeah.
Yeah, okay. Okay.
Yeah,
Absolutely.
okay, and I'm just going to do a quick introduction. Is it Macher?
Macher.
Macher.
Yeah.
Macher. You know, I'm American, so I only speak one language.
No worries. Been here a long time.
So I'm talking today with Jan Ozer, who is Senior Director, Global SaaS Solutions at Harmonic. How do you say SaaS?
SaaS. Global SaaS. Global SaaS.
Global Tech?
Global SaaS.
SaaS.
Yep.
Okay. Just like it's spelled. Global SaaS Solutions at Harmonic, about how companies using AI in its compression, in its pure compression product. Thanks for joining me. Is it Jean?
Jean.
Jean. I'm a disaster. Sorry. Jean. Sean. Jean.
Yeah, most people struggle with Jean, but if I tell you Jean-Claude, all of a sudden you don't struggle saying the Jean in Jean-Claude.
Jean, yeah. Well, he's bigger than you are.
Yes.
Okay, and again, if I'm going to mess up several times with my questions, I'll just stop and repeat myself. If you feel the need to do that, just do it. I'll cut it out during editing. So don't sweat. Jan Ozer. Hi, I'm Jan Ozer. I'm talking today with Jan Ozer, who is Senior Director, Global SaaS Solutions at Harmonic, about how the company is using AI in its pure compression product. Thanks for joining me, Sean.
Hi, John. How are you?
I'm good. So let's jump right in. Define the terms for us, because I've heard you throw around EyeQ, I've heard you throw around pure. How does all that fit together?
Yes, Pure is the core codec that Harmonic, has been developing for years. And EyeQ is machine learning models that we train to guide the pure compression algorithms, okay? So the nice thing of having that decoupling, if you'd like, is that EyeQ can work with AVC, can work with HEVC, can work with the coming, VVC codecs. It's the same principles whereby EyeQ is trained to model the human eye, and in simple terms, hide the bits where you won't see and focus the bits where you will see, okay? So we train that model on thousands and thousands of different sports content, and then we apply it, run it in our appliances, our encoders, or in our VOS platform running in the cloud to guide the compression and achieve great efficiencies. The goal really is for AVR streaming that used to be constant bitrate to now, go to variable bitrate and be more efficient for storage, for CDN delivery, et cetera, et cetera. So that's great, for streaming, and it's been a great success for us with a lot of customers using it happily.
Okay.
Some nuances that might be worth mentioning. We train and we have models specific per codec. So AVC is different from HEVC. VVC also different. And then there's also a nuance where you have to train specifically for HDR versus SDR. So this is an important also aspect of how you train the model to make it super efficient.
Okay, and VVC is something you're announcing at NAB, is that correct?
Correct. At NAB, we're showing first implementation of VVC running on our XOS encoder appliance. This is important for some regions of the world that have picked VVC as their new, codec for over-the-air delivery.
Okay. Is pure compression offered as a product or a service?
So pure compression runs in our appliances that are offered as a product. So you pay for the appliances the traditional way. Pure also runs in our VOS 360 cloud platform, and that cloud platform is offered as a service. It's a SaaS, And as such, you pay OPEX on a monthly basis.
Okay. And what's the beneficial effect of AI in IQ in terms of reduction in bit rate? Or are there other benefits that you're seeing IQ deliver besides simply reduction in bit rate?
So so it's the reduction in bit rate, that efficiency going from CBR to VBR. We assess about, if you look at AVC, and it depends on the content, but on average, it's about 50% reduction. Easier content, we get a higher percentage. The more complex, like sports, it's closer to 30%. Okay, and I'm talking about IQ for AVC. So that's the ballpark range of efficiency that you get with IQ. And then in terms of the benefits, we talked about the storage, the CDN, but that in itself means that now potentially you can reduce your ABR ladder because you might not need that many rung in the ladder. You will also have less, buffering, startup time, and profile switching. So there's a lot of side benefits, if you like, when you implement IQ. Very important, this is neutral in terms of CPU cycles. So whether you run, ABC encoding with or without it, it's a wash. And we put a lot of emphasis when we train the model. The model makes decision based not only on the input video coming in, but also on the cycles that are available at that moment. Okay. And so, yes, it's a wash for this. It's also basically available for over 100 customers that see the return, pretty much on a very short term, so that's why we had such great success.
Okay, do you have any third-party validation of those numbers beyond the customers? Any case studies or any independent studies?
We do have some studies, yes, that are available that show, with and without, and also our customers have their own analytics, that they run with and without IQ. So we have some numbers that are available, absolutely.
Okay. So one of the things that's been impacting encoding over the last few years, it's really become a three or a four-legged stool. And one of them that we haven't talked about is latency. So where do you fit in terms of latency? And the four legs I'm talking about are quality, bit rate, throughput, and latency. So and throughput is kind of the opposite twin of CPU utilization, which you already mentioned. So where do you see Pure coming in terms of latency?
So we have multiple settings for the pure codec that can, achieve different latency results. So if you want, you can reduce the latency. Of course, like you said, it's a three-legged stool, so the efficiency will have an impact. But something has to give, as we know, and the goal is to have different settings available for different use cases and applications. So people that are trying to achieve, lower latency while still doing, streaming delivery. We're not talking about a contribution use case here. They can reduce the latency. I would have to verify, but I think we go from 3 to about 1 second in the codec induced latency
Okay.
to, meet those requirements of some specific use cases. So you have three settings in our pure codec based on what is the priority. Priority could be absolutely best video quality, compression efficiency. Okay, we're still talking about real time. Well, in all three settings, or it could be priority to the latency, or it could be something in between.
Okay. So you talk a lot about machine learning with your codecs. Does the machine learning apply to the videos that a particular customer might be encoding, or are these tests you do and learning you do at headquarters and then flow those out to all the customers using the product?
Yes, so it's the latter. We take advantage of the vast library that we have with contents from all the customers through the years, and all different type of contents to train the models, and then we apply this. it's not impossible that, when the customer wants a specific training or fine tuning of the model for a use case that we have not seen, but, so far that's not been needed.
Okay. What is, I'll stop for a second. One of the things I probably should have asked about earlier is how long you've been, let me start over. When did Harmonic start implementing AI in the pure compression engine?
A little over 8 years ago. And this started as we were looking for a tool in our codec to assess, video quality. So monitoring tool to assess video quality. And we wanted something that would mimic, the subjective testing that we had been doing for years and years, right? So we came up with EyeQ. That's the genesis of EyeQ. And it delivered great results. And then it was a natural, shift to think, well, maybe we could use that model to guide the video compression, not just to monitor the VQ, right? And so that's how it started. And it was a very interesting starting point 8+ years ago to where we are today.
Okay. I mean, if I opened up one of your appliances, would I see a huge NVIDIA GPU in there, or is it running over, typical CPUs?
CPUs.
Is there any correlation between AI that requires a GPU and AI that runs fine on a CPU? I mean, looking at NVIDIA stock, it really seems like all the
Yes.
big AI is being driven by GPUs. How can you get away with, being effective with AI, but not having a GPU?
Yes, in simple terms, it's the AI-based decision, the machine learning we've been talking about, right? That guides and make decision for the compression versus the generative AI, right? And those large language models that takes humongous resources with GPU to train on, gazillion inputs of text for the most part, and now you have the multi-modal. So multi-modal meaning text, potentially video now, and that's very interesting, by the way, what those models can achieve based on video input. Maybe we'll talk about this. But anyway, in order to train those, that's where you need the resources and the efficiencies of those GPUs for those large language models training.
Okay, and you can be quite effective with a CPU for implementing machine learning.
Yes, exactly, absolutely. Yeah.
Okay. And who's using this today?
I cannot name names, but I can tell you that we have over 100 customers, paying customers that are happily using EyeQ today.
Okay. So you kind of touched on this, or at least you referred to it. Tell us about the application you're developing with Microsoft that uses generative AI in the sports arena.
Yes. So we have a proof of concept where with Microsoft, we run a lot of our cloud services on Azure. So we leverage their cognitive AI to do detections on video and audio content, and then combine that with generative AI, so GPT, from OpenAI. And the idea is that you take a soccer game or any type of live match that will be run through those cognitive AI that will detect, a lot of scenes and audio commentaries, etc. Turn that into text rendition, and then you run the generative AI on top of that text rendition to create a very accurate summary and also to extract the highlights. First of all, identify where the highlights are located, and then, make them available for use cases like a timeline in your streaming app where you have those highlights and you can seamlessly scrub back and forth on the timeline and get to see a home run or a goal, if you need to catch up quickly with the game. So those sophisticated features, that we provide in our streaming platform today they work with an app, but they need a human behind it to create those highlights, curate that timeline, if you like. If, the POC that we're doing, there are always, two dimensions to what we're testing. One is the reliability on those AI detection, and then how real time can it run, right? We don't want something that will induce a huge delay. So we focus on real time compatibility and the reliability aspect. And now you see how those simple blocks. So I get my video analysis, text, and then I render a very accurate summary with timestamps. I get my audio commentaries, text, and then same thing. I render something, very accurate. And now you can narrow down between the audio and the video detection to something that is accurate and potentially replace the human behind the timeline to create those highlights. And now you can democratize that sophisticated feature to a lot of sports that today cannot afford that, right? So that's the idea. And that's also to explain to people that you have those simple building blocks, but that get more and more, powerful every day or every 6 months. We are testing the latest of, GPT that has GPT-4 vision that is able to do even deeper analysis, more accurate analysis of video content. So this is exciting. I mean, I'm not telling you that we can run it real time today, but it's coming and it will only get better with, again, the focus on the real time and the accuracy of the detections.
Sounds exciting. And you'll be showing that at NAB?
Yes, we will be showing that at NAB, absolutely.
Okay. Listen, Sean, I appreciate you joining me today. I know time is short. Thanks very much, and I'll see you in Las Vegas.
Thank you, Jan. I'll see you there. Okay.
Okay, let me shut it off.